In this video, we'll see a few examples of push-down automata. So the question is construct a PDA for the language L is equal to A power n and B power n, where n is greater than or equal to 1. So how does the language will look like? L is equal to AB if n is equal to 1. Then it would be A power 1, B power 1. So AB. Then AA, BB. Then AAA, BBB, and etc., which implies number of A's is equal to number of B's. So the example string that I'm going to take is AAA, BBB. So you can say that the given language is accepted by the PDA when your stack is empty or you reach a final state. So how would you make the stack empty with this string? The logic would be push all the A's into the stack, and for every A you pop one B. So that way you will reach end of the stack, right? So let me draw the input tape A, A, B, 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 and epsilon for indicating end of the string. So your first input is A. So what is the logic? You push all the A's in the stack. First, initially the stack contains only the initial variable z0. So I am going to push A into the stack. Then the status of the stack is A z0. So how will you write the transition function? First one is your state, say q0. The input symbol is A. Okay. The stack status before adding input is z0 equal to, for push operation you don't have to change the state. So q0 comma, what is the start state after adding input A z0? Okay, how will you draw PDA for this q0? So I told you that everything is a self loop in push. So A is your input, stack status before adding input is z0, after adding input is A z0. Okay, first A is done. Now comes your second A. Okay, second A also you are going to push into the stack. So Z0, A, and A. Or will you write the transition function? Delta of Q0 comma A. What A is your input. What is the current state of the stack? A Z0. A Z0 is equal to, you don't change the state for push. What is the state after adding A? There are three symbols, A Z0. You write only the recent two symbols, that is Q0 comma A. So you have another transition here. The input is A, stack status is A Z0, and after adding the input, it is A. Okay. Now two A's are done. You have third A now. Again, third A also you are going to push into the stack. Z0, A, and A. Transition function is Q0 comma A, input is A, stack status is A, again Q0 comma AJ, right? Recent two symbols. So this transition is equal to this transition, right? So you don't have to write anything again in the PDA. So now all three A's are done. What do you have next? You have B. So what is the logic? For every B, you pop a A. So now you have one B. So this is the status of your stack, right? Now you have a B. So if you pop a A. So as we discussed the pop operation earlier, for first pop, so here the state is Q0. The input is B. Stack status is A, right? For the first pop, you change the state Q0 to Q1, comma. You have popped the A. What is the current status of the stack? A. Okay, how will you draw the PDA for this? You already have the PDA. So change the state to Q1. Okay, sorry. Here it should be what? Epsilon. Okay, epsilon. So the input symbol is B, state of the stack before adding input is AA, and you have done pop operation. So it is epsilon. Okay, now first B is done. You move to the second B. So for second B, you have to pop second A. What is the current status of the stack that not AA? Right. Another B is coming, so you have to pop another A. So that would be Q0, sorry, Q1. The state is Q1 now. Q1 B. Okay. The state of the stack is AA before adding the input equal to Q1 comma epsilon. Okay. For the first pop operation only you have to change the state. Okay. After that you don't have to change the state. Okay. Until it is the same symbol. Okay. If it is a different symbol and a pop operation, that case you have to change the state again. Okay. So now you have popped the second day also. So what is the so after the first pop, it is all self loop. Okay. So B is your input. State is, what is the state? AA, right? AA, comma, epsilon. Okay. Now your second B is also done. Move on to the third B. Third B are popping third A. So A Z naught is the current status. You for every B you are popping one A. The transition is Q1. Input is B. The status is A Z naught equal to Q1 comma epsilon. So how will your PDA transition look like? Input is B. State is A Z naught. You're popping. That's why epsilon. Okay. Now all your B's are A's and B's are done. You got epsilon at the end. Now your symbol is epsilon and the stack state is just Z naught. Right. And the symbol that you have is epsilon. What will you do? You have to make the stack empty, right? So when the epsilon comes, you pop Z naught. So transition is Q, sorry, delta of Q1 is your state, input is epsilon, okay, stack status is Z naught. So this is a different symbol. Epsilon is a different symbol, it is not B. So you change the state to Q2, comma, you're popping, that's why epsilon. So what will you do in the PDA? You move the state to Q3. Okay, what is the transition? Your input symbol is epsilon. Okay, stack state is Z naught. You're popping, so epsilon. So this is your final PDA with all the transitions. Hope you understood.